Balanced and Unbalanced Forces, Fan Cart Lab. I can demonstrate and calculate how unbalanced forces change the speed or direction of an object's motion. Your starter, agree or disagree? On the next slide, move each statement card under agree or disagree. Be ready to justify your answers. So on our agree side, objects can continue to move in a straight line without a force being applied. Objects will continue to move in a straight line without a force being applied because once an object is in motion, it will continue in motion until affected by an unbalanced force. So all objects should continue in a straight line, continue moving until an outside force is applied to them. Such an outside force would be something like friction opposing the force when two surfaces touch one another, or gravity can slow down an object and cause it to stop. Forces act on objects at rest. This is true. So an object that's at rest and is not moving, there's still forces acting upon the object. They're balanced, so you don't see the object moving. But if you have your phone resting on your desk, your phone is exerting a force on the table, and the table is exerting a force on your phone. A force is necessary to change the direction of motion. An unbalanced force is necessary to change the direction of motion. When an object is moving, there's always a force in the direction of its motion. Not necessarily. When an object is moving, it always moves in the direction of the force. Moving objects stop when their force is used up. No, a force is never used up. A force is a push or a pull. So once a force is applied, that object should continue in motion, but unbalanced forces cause it to slow down and stop, again, like gravity or friction. Constant speed results from constant force. This is incorrect. You do not need a constant force in order for an object to be in motion. If there's no motion, then there's no force acting on it. This is not true because we understand when an object's at rest, there's still forces acting on the object. It's just that the forces are balanced. There cannot be a force without motion. Unbalanced forces cause motion. The stronger the force, the faster an object moves. Well, the stronger the force, the greater the acceleration, and acceleration means to increase speed, decrease speed, or change direction. So let's define for practice balanced and unbalanced forces. Balanced forces do not cause a change in motion. Objects will remain stationary, or remain in motion at the same speed and in the same direction. Unbalanced forces changes the motion of an object, causing the object to speed up, accelerates, slow down, decelerates, or change direction. So today we're going to have a fan cart lab, and for the activity we're going to click on the carts and it will take us to an interactive website. Once there, we're going to click on the red circle for cart 1 to make the carts move. So this brings us to part 1, which we're on, and I'm going to press the start button to turn on cart 1, and I'm going to observe the motion and the speed. This is your speedometer up here telling us how fast or slow the fan carts are going. So as you can see, your speed increased, okay? And here you can see that the cart is moving to the right, in the direction towards the right, because you can see this kind of red air following past the fan. So I'm going to go back to our lab, and it's asking us to move the vectors to show the motion of the carts. So when we turned cart 1 on, the carts went to the right. So the motion of the cart moves to the right. Are the forces balanced or unbalanced? Because why? Well, the forces here are unbalanced because at first the cart was at rest. The forces were balanced. But when we turned the fan on, we had an unbalanced force causing the cart to increase speed. All right, now let's go to part 2. So we're going to click on the carts to take us to the interactive website. Once there, we're going to click on the circle for cart 1 and cart 2 and make the carts move and make observations. So it's still on part 1 over here, so I have to switch to part 2. And here is my button that's going to turn on both carts 1 and 2. Here's cart 1, here's cart 2. And I'm also going to look at my speed. So here we go when we turn on both carts. So you can see your speed increased, okay, and you can see that the carts are moving towards the right with increasing speed. So I'm going to go back to my lab, and I'm going to place my vectors above the fans to indicate the direction of the carts. The motion of the cart system in part 1 and part 2 are similar because cart 1 and cart 2 both move to the right with increasing speed. The forces are unbalanced because there's a change in motion. The carts are increasing speed. Let's go to part 3 now, and we're going to click on the carts to take us to that interactive website. Once there, we're going to click on the red circle for cart 1 and then cart 2 to make the carts move. So I'm in part 3, so I want to click. I can reset or refresh with this button here. Okay, so now I'm on part 3. And I have my control button for cart 1 and my control button for cart 2. So I'm going to watch my speed and the fans. So I see that fan 1 is on and I'm increasing speed. Okay. Now I'm going to click on cart 2 control panel. Okay, and what I see again is that both carts are moving to the right with increasing speed on part 3. Okay, so how does the motion of the cart change? Carts move to the right. Are the forces balanced or unbalanced? I'm having an unbalanced force because the motion of the cart changes and the cart's moving with increasing speed. All right, now we are on part 4 and 5 of the activity. So we're going to click on the carts to take us to that interactive website. Once there, we're going to click on the red circle for cart 1 and then cart 2 to make the carts move. Okay, so we are in part 4. And I'm going to turn on carts 1 and 2 and observe. Okay, so when I turned on cart 1 and 2, I still see there's no motion. When there's no motion, my forces are balanced. Okay, so I'm going to click on cart 2 now. Okay, maybe I have to turn off my cart 1 and 2, and now I can click on cart 2. Oops. Okay, so here it's just that they were balanced, so you can see this cart is moving to the left and this cart is moving to the right, and we have balanced forces. So there's no motion, carts are stationary, our forces are balanced, there's no change in motion in step 4. Okay, now I'm going to go to step 5, and I'm going to press the button for cart 1 and 2. Okay, they're balanced, but what happens if we give a push to these balanced carts? So let's do that. Let's push the cart. And so look at my speed. My speed increased, but then it's remaining constant. So once that unbalanced force takes place, okay, and those carts should continue in motion without that applied force, okay, if there's no friction opposing the carts. So I'm going to go back here, and I can say in step 5 a push was added and the carts became unbalanced. When in motion the carts had a constant speed, so the forces became balanced again. Now we're in part 6. I'm going to click to get to the interactive website, and I'm going to click on the red circle for cart 1 and cart 2 to make the carts move. Okay, let's make sure we're in part 6. I have to refresh. Alright, now I'm in part 6, and I'm going to turn on cart 1. So as you can see, this cart is moving to the right with increasing speed. Okay, now I'm going to turn on cart 2 and see what happens. So here I can see that cart 2 is trying to move to the left. Okay, so what I'm going to do now is turn off cart 1 and see what happens. Alright, so now what I see here is that cart 2 is moving to the left with increasing speed. And then if I turn it off, you can see that same effect. So let's go back to our lab, and it says, how does the motion of the cart system in part 6 compare with the motion in car system part 5? In part 6, the carts moved to the right, and in part 5, carts were motionless because the forces were balanced. The forces, are they balanced or unbalanced? Here, the forces were unbalanced because the motion of the cart changed. So for your connection and exit today, we have a STAR test question. It reads, the diagram below shows a sled moving along a smooth, frictionless track. Here's your sled, and it's going to go along this frictionless track, meaning that nothing is going to slow it down. It will just keep moving. In which sections of the track will the sled experience an unbalanced force? Remember, unbalanced forces change the motion of an object. So here, right now, the sled is at rest, okay, and it looks like it would be the same position in section 3. If you look at section 2, as the sled goes down the hill, you would imagine it increases speed. So we would change the motion. We would make it go faster, right? And once the sled goes up section 4, it's going to be going uphill, where we'll be decreasing speed. So we will be changing the sled's motion. So the answer is C. In section 2 and in section 4, the motion of the sled changes. It increases speed as it goes downhill, and it decreases speed as it goes uphill.